All right, today we're talking about Starlink. You've probably heard of it, this massive, audacious plan to build a highway in the sky. But the real question we're digging into is this. Can a giant swarm of satellites actually connect the last billion people on Earth? Let's get into it.
Okay, just for a second, I want you to imagine something. What if getting online had nothing to do with your bill or which company you picked? What if, just because of where you lived, say a remote island or deep in a jungle or in some mountain valley, it was just physically impossible to get a connection? Like no way, no how.
Well, here's the thing. That's not just some thought experiment. For over 1 billion people on this planet, that is their everyday reality. 1 billion people. We're talking about the last billion, a huge population basically living in an information vacuum, completely cut off from the digital world we all take for granted.
So why? How is that even possible today? Well, it's not just about money, though that's part of it. It's really a fundamental problem of, well, physics. The old ways we used to connect the world, they've just completely hit a brick wall.
So here's the breakdown of the problem. You've got two old school options. First, there's fiber optic cable. Yeah, it's super fast, but it is ridiculously expensive to lay, especially over mountains or through jungles. We're talking up to $120,000 a mile. So if you don't have a ton of customers in one spot, companies just won't build it. Then you've got the old satellites, the geostationary ones. They cover a lot of ground, sure, but they are so far away that the signal lag, what we call latency, makes stuff like Zoom calls or online gaming just impossible. It's a terrible choice, right? The unaffordable or the unusable.
And this is where everything changes. Starlink comes in with a completely different approach. Low Earth orbit satellites, or LEO. The secret sauce here is just one thing: altitude. Starlink satellites are about 60 times closer to Earth. And that proximity? It just slashes the signal delay down to 20 to 40 milliseconds. That's basically the same as the fiber you'd get in a major city. So you see, this isn't just a small improvement, it's a whole different ballgame.
I mean, just look at this chart. It lays it all out crystal clear. That huge bar on the left, that's the old GEO satellites. And that tiny little sliver on the right, that's Starlink. We're talking about a difference of over half a second in response time. And that might not sound like a lot, but it is the massive chasm between a frustrating, laggy, totally broken experience and a smooth, real-time video call where you can actually talk to someone. It's not just about download speed. It's about making real human interaction possible online.
Okay, so how does Starlink actually pull this off? How do they build this highway in the sky? Well, it comes down to some really cool technology that basically makes physical distance irrelevant.
The real magic trick here is something called optical inter-satellite links. Now that sounds complicated, but just think of it like a mesh network, made of lasers, in space. Seriously, data zips between the satellites themselves, hopping from one to the next. And because it's traveling through the vacuum of space, light actually moves faster than it does in a fiber optic cable on the ground. This is the key. It's what lets Starlink deliver internet to the middle of the ocean or a huge desert with 0 ground stations anywhere nearby.
And down here on Earth, getting connected is just as clever. The user terminal, which everyone affectionately calls Dishy, isn't your old-school satellite dish. It's got this smart phased-array antenna that tracks the satellites flying overhead electronically. No moving parts, nothing to break. And the best part? It's designed so you can set it up yourself in minutes. That gets rid of a huge barrier. You don't need a technician. Now there's even a mini kit that literally fits in a backpack and can run on solar power. I mean, you can't get much more remote-friendly than that.
Okay, so the tech is obviously super impressive, but what does it actually mean for people? Let's shift gears and look at the real-world impact. We're going to see how this is actually changing lives right now.
First up, education. The impact here is just massive. Take schools deep in the Amazon. They went from struggling with less than 2 megabits per second, barely enough to load an email, to over 100. All of a sudden, they can do video learning, they can digitally preserve their culture. And it's not just there. On the Navajo Nation in the US, students used to have to drive for miles, sometimes for hours, just to find a Wi-Fi spot to do their homework. Now, they can log into a live Zoom class right from their own homes. That's a total game changer.
And what about healthcare? It's just as profound. In Zimbabwe, there's this project called Zim Smart Villages. They're using Starlink to connect rural clinics with specialists in the big cities. And because the latency is so low, they can do high-def video calls. Think about what that means. Patients are getting diagnosed and getting prescriptions from top doctors without having to make a grueling multi-day trip. It is, quite literally, saving lives.
It's even changing how we grow food. Out in the world of agriculture, this kind of connectivity is turning farming into a data science. Tractors, sensors, drones, they can all upload data in real time from the middle of a field hundreds of miles from anywhere. And by analyzing all that data, farms can be way more efficient. We're talking about cutting water use by 20% and fertilizer by 30%. That is a massive win, both for the farmer's wallet and for the environment.
Okay, but it's not all a perfect success story. Because even though Starlink has torn down these huge physical and technological walls, some brand new walls have popped up to take their place.
And this table really shows you the new reality. Look, in the US, the cost is what it is. Maybe a bit pricey, but manageable for many. But now look at Nigeria. That price, even when adjusted, is just completely out of reach for the average family. Then you've got places like Kenya trying new rental models to make it work. And then there's South Africa, where it's just plain blocked by regulations. It's such a clear sign, isn't it? The technology might work everywhere, but the economics and the politics are still very, very local.
So people were getting creative to solve this cost problem. Instead of the one dish per family model, they're thinking bigger. One really smart idea is called B2B backhaul. Basically, a cell phone company like Airtel Africa uses one Starlink terminal to provide the internet for a whole cell tower. So suddenly, an entire village gets 4G on their normal phones. Nobody has to buy a dish. Another great approach is the community gateway. One powerful terminal provides Wi-Fi for a whole town, and the cost gets split between hundreds of people. It's all about sharing the connection.
And all of this leads to a really fundamental question, maybe the question of our time. If the internet signal itself is borderless, if it's just beaming down from space, who gets to decide who can use it? Really, who controls the sky?
Which brings us to the absolutely fascinating paradox of South Africa. Officially, Starlink is blocked there. The government has these local ownership laws that Starlink doesn't meet. But the demand is so incredibly high that a huge gray market has exploded. Thousands of people are secretly importing the kits from other countries and just using them on a roaming plan. It is the perfect example of this massive clash between a country's internal politics and the unstoppable, overwhelming demand from people who just want to be connected.
So, with all these new economic and political challenges in the mix, where does all this go from here? What's next for connecting the rest of the planet? Well, the next huge leap forward is something called direct-to-cell, and honestly, this could change everything. The idea is that the next generation of satellites will basically act like cell towers, but in space. They'll beam a signal directly to a normal, standard smartphone on the ground. Just think about that for a second. No dish, no special hardware. It could completely eliminate the cost of entry for basic internet, connecting literally anyone who has even the most basic phone.
And believe me, the landscape is changing fast. Competition is finally showing up. Amazon's Project Kuiper is getting ready to launch its own constellation, and that should hopefully drive prices down for everybody. But there's another side to this. As more and more companies launch thousands or even tens of thousands of satellites, a whole new problem comes up. How do we manage all of that stuff up there without creating a huge, dangerous space junk problem?
So, here's where we land. Starlink has pretty much proven that the digital divide isn't a geography problem anymore. The technology can reach anywhere. The new walls, they're economic and they're political. And that leaves us with a huge, critical question for our future. If we now have the technology to connect every single person on Earth, who's responsible for making sure we actually do it?